Welcome back to another video of Standard 10, Chapter 1 Ncert textbook. We can discuss the exercises. Exercises 1.4. First question. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating decimal expansion. Some rational numbers are given. We have to check whether it has a terminating decimal expansion or non-terminating decimal expansion. We can also see the second question together. Second one, write down the decimal expansions of those rational numbers in question 1 above which terminating decimal expansion. Also, we have to write the decimal expansion of those rational numbers with a terminating decimal expansion. We can see the solution. First question was 13 by 3125. We have to check whether it has a terminating decimal expansion or non-terminating decimal expansion. By theorem, we know that if denominator is the form 2 raised to m into 5 raised to n, then it have a terminating decimal expansion, and if it is not of the form 2 raised to m into 5 raised to n, then it have a non-terminating repeating decimal expansion. We can see the prime factorization of 3125. 3125 is 5, 6, 2, 5, 625, again 5, 1, 2, 5, 125, again 5, 2, 5, 25, again 5. Here this can be written as 13 by 3125 is 5 raised to 5. Here see the denominator is of the form 2 raised to m into 5 raised to m with the m equal to 0 and n equal to 5. Therefore it has a terminating decimal expansion. Or we can write here denominator is of the form 2 raised to n into 5 raised to m, where n equal to 0, m equal to 5. Therefore it has terminating decimal expansion. The second part of the question was that if it has a terminating decimal expansion, we have to find the decimal expansion. Here 13 by 3125 has a terminating decimal expansion. Therefore we have to find the value, which is equal to 13 by 5 raised to 5. To convert it to the form the power of 10, we can multiply the numerator and denominator by 2 raised to 5. Then 13 into 2 raised to 5 by 5 raised to 5 into 2 raised to 5, which is equal to 13 into 2 raised to 5 is 32 by 10 raised to 5, which is equal to 416 by 10 raised to 5, which is equal to, here after the decimal we have 5 values. Therefore 0.00416. Second question is 17 by 8. Clearly 17 by 8 is equal to 17 by 2 cube. Here the denominator is of the form 2 raised to n into 5 raised to m with n equal to 3, m is equal to 0. Therefore it has a terminating decimal expansion. Therefore terminating decimal expansion. Now the second part is, if it has a terminating decimal expansion, we have to find the value. Now 17 by 2 cube is equal to, now to make the denominator to power of 10, we can multiply by 5 cube. 17 into 5 cube divided by 2 cube into 5 cube. which is equal to 17 into 125 by 2 into 5 the whole cube, which is a 10 cube, which is equal to 125 into 10 is 1250 and plus 125 into 7 is 35, 17, remaining one 7, 8 plus 875, which is equal to 5, 2, 1, 1, 2. 2125 by 10 cube, which is equal to, after the decimal, 3 values. Therefore, 2.125. Third question is 64 by 455. See the factorization of 455. 455 is 5, 9, 1, 91. Here 7, 3, 13. Here which we can write 64 by 5 into 7 into 13. Clearly the denominator is not of the form 2 raised to n into 5 raised to n. So it has a non-terminating repeating decimal expansion. Not of the form q, not of the form 2 raised to n into 5 raised to m. Therefore non-terminating, it has a non-terminating repeating decimal expansion. We need not find the value. Next question, 15 by 1600. Now see, it is 15 by 16 into 100, or we can write 15 by 16 is 2 raised to 4. 2 raised to 4 into 100 is 10 square, which is equal to 15 by 2 raised to 4 into 10 square is 2 square into 5 square, which is equal to 15 by 2 raised to 4 into 2 square, which is 2 raised to 4 plus 2, 2 raised to 6 into 5 square. Here is of the form 2 raised to n into 5 raised to m, with the n equal to 6 and m equal to 2. Therefore, it has a terminating decimal expansion. Now, the second part of the question, if it has terminating decimal expansion, we have to find the value. To find the value, 15 by 2 raised to 6 into 5 square, we can multiply the numerator and the denominator by 5 raised to 4, which is equal to 15 into 5 raised to 4 by 2 raised to 6 into 5 raised to 6, which is equal to 5 raised to 4 is 5 square into 5 square, 25 into 25, 625. 15 into 625 by 10 raised to 6. Now 15 into 625 is 625 into 10 is 6250, and 625 into 5 is half, 3125. Here 5, 7, 3, 9, 9375, which is equal to 9375 by 10 raised to 6, which is equal to, after the decimal we need 6 value, 0.009375. Next question, 29 by 343. 343 is 749. 7 cube, 29 by 7 cube. Not of the form 2 raised to n into 5 raised to m. Therefore, it has a non-terminating repeating decimal expansion. Not of q, not of form 2 raised to n into 5 raised to m. Therefore, it has a non-terminating repeating decimal expansion. See, next question, 23 by 2 cube into 5 square. Clearly it has the denominator 2 raised to n into 5 raised to m form with the n is equal to 3, m is equal to 2. Therefore, it has a terminating decimal expansion. Now, to find the value, we can say 23 by 2 raised to 3 into 5 square. We can multiply by 5, both the numerator and the denominator. We will get 23 into 5 by 2 cube into 5 cube, which is equal to 23 into 5 is 23 into 10 is 230. Therefore, its half is 115. 115 by 10 cube, which is equal to 0.115. Next question. 129 by 2 square into 5 raised to 7 into 7 raised to 5. Clearly, which is not of the form 2 raised to n into 5 raised to m. The prime factorization of q contains the factor 7 also. So it is non-terminating repeating. Not of the form q, not of the form 2 raised to n into 5 raised to m. Contains the prime 7. Therefore, non-terminating repeating. Next question. 16 by 15, which is equal to 16 by 15 is 3 into 5. Not of the form 2 raised to n into 5 raised to m. Therefore, non-terminating repeating. Q not of the form 2 raised to n into 5 raised to m. Therefore, non-terminating repeating. Next question. 35 by 50. 50 is a 5 into 10. 35 by 5 into 10 is 2 into 5. 2 into 5. Or 35 by 2 raised to 1 into 5 square, which is of the form 2 raised to n into 5 raised to m, with the n is equal to 1, m is equal to 5. Q of the form 2 raised to n into 5 raised to m, with n is equal to 1, m is equal to 2. Therefore, terminating. Now we have to find the value. Since it is terminating, we have to find the value. Now 35 by 50 is equal to 35 by 2 into 5 square. We can multiply the numerator and denominator by 2 to get 10 square, power of 10, which is equal to 35 into 2 by 2 square into 5 square, which is 35 into 2 is 70. 70 by 10 square, which is equal to 0.70 or 0.7. And the last question here is 77 by 210. See the factorization of 210. 210 is here 2, 105, here 5, 21, 3, 7. Therefore, 77 by 210 can be written as 77 by 2 into 5 into 3 into 7. Here, denominator is not of the form 2 raised to n into 5 raised to m. Therefore, it is non-terminating repeating. Q not of the form 2 raised to n into 5 raised to m. Therefore, non-terminating repeating. The last question of this section. Third question. The following real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form p by q, what can you say about the prime factors of q? Here three real numbers are given. We have to say whether they are rational or not. And if they are rational and of the form p by q, we have to say something about the prime factors of q. See the answer. First one, 43.12345678, which is a terminating decimal expansion. We know that rational numbers are two types. One is with the terminating decimal expansion and second one is rational numbers are of the form non-terminating repeating decimal expansion. See first question, it is a terminating decimal expansion. So this is a rational number. Therefore, we can say the first question, it has terminating decimal expansion. Therefore, it is a rational number. If they are rational and of the form p by q, what can you say about the prime factors of q? Since it has terminating decimal expansion, we can say that it's a denominator, or q has the prime factorization of the form 2 raised to n into 5 raised to m. Therefore, we can write it as a rational number and of the form p by q with the q with the prime factorization of q 2 raised to n into 5 raised to m. Or we can say that prime factors of q are either 2 or 5 or both 2 and 5. Or we can say prime factors of q are either 2 or 5 or both 2 and 5. No other prime factors in the factorization of q. See the second question, 0.120, 1200, 12000, etc. This is non-terminating but not repeating. So this is not a rational number. Rational numbers are either terminating or non-terminating repeating. Here this is non-terminating and non-repeating. Therefore, we can say that it is not rational. Since not repeating, or we can say that since it is non-terminating but not repeating. See the next question, 43.12345678, again 1 2 3 4 5 6 7 8 9 repeating. So this is non-terminating repeating. So we can say that it is a rational number. And rational number of the form p by q with the prime factors of q contains factors other than 2 and 5. Okay, we can write it is rational because decimal expansion is of the form, it is of the form non-terminating repeating. Now what can you say about the prime factors of q? Now It's a rational and of the form P by Q with the Q contains factors other than 2 or 5. Or we can write prime factors of Q will also have a factor other than 2 or 5. Or Q is not of the form 2 raised to n into 5 raised to m. Okay, chapter 1 is over. This is my last part of the first chapter, real numbers. Hope all you understand this chapter. If you have any suggestions or any comments, please comment below. See you again with another chapter. If you have any suggestion on chapters, please comment.